Welcome. Our mission today is a deep dive into some real historical paradoxes. We're looking at physical evidence artifacts, huge structures that, well, based on the traditional timeline of history, really shouldn't exist.
Right. It's the ultimate puzzle. We're talking about remnants that show a sophisticated technical knowledge in fields like mechanics, precision manufacturing, even advanced chemistry.
And this is centuries, sometimes millennia, before we thought these cultures had that kind of capability.
Exactly. It forces you to ask, what else don't we know? These things challenge our whole timeline of innovation.
In some cases, we're talking about technology that modern scientists are still struggling to fully understand or even replicate. But to begin, I think we have to start with the most famous mechanical marvel ever pulled from the sea. Let's get into the incredible complexity of the Antikythera mechanism.
What's so fascinating is how close this object came to being completely lost. It's a Greek artifact from the Hellenistic period, so we're talking late 2nd, maybe early 1st century BCE. It was salvaged from a shipwreck back in 1901.
And for a long time, it just looked like a piece of junk,
For
right?
decades, just a corroded green mass of bronze. Nobody knew what it was. It wasn't until scientists began using, really sophisticated imaging.
X-rays and CT scans.
That's right. And they realized they were holding the oldest, most intricate example of an analog computer ever found.
It just seems almost impossible to fit that level of complexity into that era. I mean, finding a 30-gear computer from ancient Greece, what does that change?
It changes everything. I mean, this wasn't just a simple gearbox. The mechanism used at least 30 precisely manufactured meshing bronze gears.
And what were they for?
They were designed for some incredibly sophisticated calculations, things like predicting astronomical positions, modeling the irregular motions of the moon,
Eclipses, too, I read.
solar and lunar eclipses, yes, and it even tracked the 4-year cycle of athletic events like the ancient Olympiad.
To make 30 gears that actually mesh and work smoothly, that implies a huge technological base, not just one genius inventor.
It absolutely does. The level of mechanical sophistication, the intricate differential systems, we just didn't see that again in Europe until the 14th century.
With the first big mechanical clocks.
Exactly. So that's a 1,500-year technological gap. The Antikythera mechanism suggests a whole lineage of workshops and skilled artisans that, well, we've found no other trace of.
And there are still mysteries about it. I mean, the researchers think parts are still missing, right?
They do. They speculate there were other components that would have calculated the positions of all 5 of the classical planets known to the Greeks.
So if the Greeks could master that kind of mechanical precision, let's pivot to a different kind of precision. How the Tiwanaku civilization, centuries later, mastered geometric precision on a monumental scale. Let's talk about Pumapunku.
Right, in Bolivia. This site is just a masterclass in precision engineering, but on a massive scale. We're talking about enormous stone blocks, some red sandstone, some andesite, some of them weigh up to 130 tons.
And just moving them is a feat in itself.
Oh, it's astounding. But the movement isn't even the biggest mystery. It's the fit, the design philosophy.
Describe this masonry for us, because these aren't just, stacked rocks.
Not at all. They are perfectly cut, interlocking pieces of stone, engineered like giant, sophisticated puzzle pieces or like massive Legos fitted together with no mortar at all.
And the joints are legendary.
They are. The masonry is so accurate that people have said for centuries you can't pass a razor blade between these massive blocks.
It's just mind-boggling.
Yeah.
And how did they keep these things together, especially in an area that has earthquakes?
Well, they used some really advanced tectonic engineering. They actually secured the stones with these cast-in-place eye cramps.
Metal clamps.
Yes, made from a very specific bronze alloy copper, arsenic, and nickel. They would pour the molten metal directly into sockets they'd carved in the stone.
So is the metal cooled?
It contracted,
Yeah.
and it would pull those massive blocks together with immense force. We're talking up to 44 kilonewtons. It's an early use of, thermal physics for structural stability.
That kind of standardization is just fascinating. It sounds like something from the industrial age.
That is the key takeaway. The Tiwanaku style used these standardized geometric blocks. You could reproduce them. It suggests an understanding of, prefabrication.
Which is so different from the Inca style later on with their irregular stones.
It's a completely different philosophy. And it raises the big question. What kind of tools let them get those flawlessly smooth surfaces and perfect, sharp interior right angles, especially in a stone as hard as andesite?
It's a real riddle.
Yeah.
We see the result, but not the process. Okay, let's move from mechanics and architecture to material science. Let's talk about Roman concrete.
The durability puzzle. It's one of the biggest questions in modern civil engineering. You have Roman structures, like the Pantheon, that have survived for over 2,000 years, often in harsh marine environments.
While our modern concrete starts crumbling after just a few decades in the same conditions. So what was their secret?
Well, we've known for a while it involved volcanic ash and lime, but a recent breakthrough is about how they mixed it.
Right, the hot mixing.
Exactly. It goes beyond just the ingredients. New research suggests the Romans achieved this phenomenal durability by deliberately hot mixing using quicklime, that's calcium oxide, instead of just the normal slaked lime.
And this hot mixing created what you could call a flaw in the material, but that flaw was actually its greatest strength.
Precisely. This rapid heating process left behind these little highly reactive aggregate scale components. They're called lime clasts.
And these weren't fully mixed in.
No, they acted as these critical localized sources of reactive calcium.
So they're like internal repair kits, just waiting inside the concrete.
That's a perfect way to put it. When a tiny crack forms, water gets in. That water interacts with the calcium in these clasts, and it creates this calcium-rich fluid.
Which then fills the crack.
It leaches into the crack where it recrystallizes and hardens. It seals the damage from the inside out. We've actually done experiments with modern Roman-inspired mixtures, and they successfully healed cracks up to 0.5 millimeter wide.
That is the ultimate sustainable material. It's designed to get stronger.
It has profound implications. And this wasn't their only material marvel. Think of the Lycurgus cup,
The color-changing Roman glass.
a 4th century cup that looks green in normal light, but glows a deep ruby red when you shine a light through it.
How did they do that?
By embedding gold and silver nanoparticles into the glass, it's essentially an example of nanotechnology 1,600 years ago.
And what about Greek fire? The Byzantine weapon that even burned on water.
Another chemical mystery, the composition was a state secret, and the exact formula is, well, lost to time. It just shows a level of chemical control that we still can't quite replicate.
So let's shift from chemistry to artifacts where the mystery is the message or just the sheer scale.
Well, you have to talk about the Piri Reis map. It was created in 1513. It's a world map, and he noted that he based it on older source maps, some possibly from the Hellenistic era, and for its time, it's remarkably accurate.
But there's one part of it that just stops historians in their tracks. It's the depiction of Antarctica, isn't it?
It is. The map seems to show an accurate outline of the Antarctic coastline, possibly before it was covered by its current ice sheet.
But Antarctica wasn't officially discovered until 1820.
Right, so it raises a fundamental question. Did Piri Reis have access to source maps from a much older civilization, one with global exploration technology? It suggests a transfer of knowledge from a source we just can't identify.
From maps to massive drawings on the Earth itself,
Yeah.
we have the Nazca lines.
Down in the Peruvian desert, yes. Created between 500 BCE and 500 CE. These are giant geoglyphs. Some figures are over 1,200 feet long, and you can only really see what they are from the air.
So the question isn't how they made them, it's why, and how they got the scale so perfect.
Exactly. To draw a figure that large and keep it proportionally accurate so it looks right from high above, you'd need a really sophisticated system of surveying and geometric planning.
You're talking about organizing huge teams of workers following a complex blueprint over miles of terrain.
And ensuring the lines stay perfectly straight over that undulating terrain. The methods they must have used are still being debated. It implies an incredible level of societal organization for a purpose we don't fully understand.
So all of these anomalies, the gears, the concrete, the maps, they spark these polarizing debates.
Mhm.
You often hear this theory that dogmatic academics reject these things to protect the status quo.
We should probably step back and look at how the academic process actually works. A true academic or historian would be thrilled to find credible evidence that rewrites the history books. I mean, why wouldn't they?
Right, because that's a career-defining discovery.
It guarantees original research, new funding, conferences. Academic consensus is actually built on challenging what we think we know.
So this idea of a conspiracy of silence, it kind of misunderstands how science and history progress.
It does. The core difference between a speculative theory and accepted history is the requirement for strong, verifiable evidence.
And that's where things like X-ray tomography and chemical analysis come in.
They are the key. These artifacts are a humbling reminder of human ingenuity, and we have to rely on the science of the artifacts themselves to unlock their secrets, not just speculation.
So today we've gone from nanoscale engineering in Roman glass to ancient computers and megalithic puzzles.
And the most profound discoveries aren't always the biggest. The lessons from Roman concrete, understanding those lime clasts and their self-healing function, that has direct, immediate use today.
For building more sustainable, more resilient, modern infrastructure.
We have to learn from the past to build a better future.
So if you consider that one of Rome's greatest technological secrets was a material designed to get stronger over time, what other ancient lost arts might hold the key to solving our most pressing modern challenges? If we just look closely enough, what knowledge is waiting for us in the next layer of dust?